Water, one of the most powerful forces on the planet, plays a crucial role in creating life and destroying it. In its most deadly form, it creates a killer wave, also known as a tsunami. Water traveling faster than a jet plane has enough power to not only demolish vehicles and lampposts, but also buildings, dragging along everything and everyone in its path. Tsunamis are usually the result of a submarine earthquake, but can also be triggered by landslides and volcanic eruptions. Earthquakes occur between the Earth's crust and the layer directly below the crust. Together, the crust and the upper mantle make up the lithosphere. This is divided into 8 major and many minor segments, known as tectonic plates, which encase the Earth in a jigsaw-like puzzle. In the lithosphere, the rocks are very brittle and so have a high likelihood of cracking. The plates are under a layer of rock which is heated so it can move while remaining a solid. Whilst these tectonic plates on average only move a few centimeters per year, when this happens, there is an increase in tension between the plates. This tension builds up and eventually the plates are thrust up or down, with one plate subducting the other. There are 2 main types of tectonic plates, and it is the interaction between these continental and oceanic plates that are the main causes of history's most devastating tsunamis. Many earthquakes occur at the boundaries of these tectonic plates, which are called faults. The tension that builds up at said faults eventually becomes too much for the plates to contain. The plates move under horizontal forces that cause them to collide, combine, break up, or, in the case of oceanic plates, to be drawn down, subducted. Eventually, the pressure of the bottom plate pushes back up again, causing a megathrust. The plates can shift in different directions, side to side, over one another, or up and down. The slips range from anything from 1 inch to 33 feet. This shift is the earthquake. It releases all of its energy from the epicenter, as well as releasing seismic waves resulting in terrestrial tremors. Tsunamis can occur when earthquakes transpire underwater. Since plates can shift drastically, this can not only release energy into the water, but also cause displacement. This large displacement can lift the water up, pushing it forward. As the water starts to move, it picks up more energy and starts to form a wave. The deeper the wave, the faster a wave. But as it approaches the shore, the wave slows down, builds up, and becomes a very large wave before crashing down on land. Whilst it is often likened to a wave, its behavior is far more similar to a very fast and very strong tide. Although rarer, tsunamis could also be caused by submarine landslides and volcanic eruption. Submarine landslides typically occur as a result of an earthquake, which causes coral and rocks to slide away, thus resulting in large amounts of water being displaced. The water level then rises, generating large waves. The technical term for a tsunami caused by landslides is megatsunami. Megatsunamis have considerably higher amplitudes than typical tsunamis because the sheer amount of water displaced results in a wave size greater than a submarine earthquake. Because the sheer amount of water displaced results in a wave size greater than a submarine earthquake. When a submarine volcano erupts, it forces ash and debris into the water. The sudden change in displacement of water transfers to kinetic energy and results in seismic waves. The more debris, the higher the amplitude. Submarine volcanoes, like landslides, can collapse downward or spew lava, heating the surrounding water, thus disrupting huge volumes of water, which could potentially lead to seismic waves. Tsunami can only happen near large bodies of water with no seasonal constraint. They have a higher risk of occurring in the Ring of Fire, an area in the basin of the Pacific Ocean, bordering the edge of several tectonic plates that meet along the Ring of Fire, making the area more vulnerable to the direct result of plate tectonics and the movement and collisions of lithospheric plates. The Tohoku earthquake and tsunami occurred in Japan on the 11th of March 2011. At 1446 Japan time, the earthquake occurred and lasted for around 6 minutes. It was initially reported of having a magnitude of 7.9, which was eventually upgraded to 9.0. The earthquake took place along the border between the North American and Pacific plates. The earthquake was of the megathrust variety. The Pacific plate subducted under the North American plate, causing the seafloor to rise by several meters. This kinetic force, coupled with the displacement of water, caused a tsunami. The majority of deaths and loss of property came from this resulting tsunami. Sendai was the nearest major city to the earthquake. 373 kilometers from Tokyo. More than 15,800 people were killed, and more than 2,600 others were missing. Hundreds of thousands of people were left homeless. This disaster also sparked emergencies at several nuclear power plants along the Honshu eastern coast. The World Bank's estimated economic cost was $235 billion, making it the costliest natural disaster in world history. Japan has had a long history of natural disasters, and its government has invested a large amount of money into tsunami and earthquake warning systems. Before the 2011 earthquake, they prided themselves on their advanced warning system, yet when the earthquake occurred, the Japanese Meteorological Agency, the JMA, underestimated the size and impacts of the earthquake and tsunami. The tsunami warning systems only calculated the tsunami magnitude in the first minute, so it severely underestimated its size. In the first minute of the earthquake, the tsunami was expected to be only 50 centimeters high. However, in the second minute, that number jumped to 10 meters. The JMA underestimated the magnitude and released data that it was only 3 meters. People were not as scared, and this cost Japan hundreds of lives. Similar to many other countries and cities dotted around the Pacific Ocean which are prone to earthquakes and tsunamis, there are many deep water assessment and reporting of tsunami stations located just off the coast of Japan. The data that is collected every minute from these buoys use pre-computed generation propagation forecast database to predict the magnitude and impact of these earthquakes and tsunamis. Both SIFT and DART technology work together to provide ample knowledge of tsunamis before they hit. The Japanese government also has mandatory education regarding earthquakes and tsunamis, so many people can tell the difference between P and S waves. Since P waves come before S waves, there is about 3 minutes after the initial shock waves to seek cover or find safety. The JMA has advanced tsunami prediction technology, though still underestimated the magnitude of the tsunami wave. Upon receiving data regarding the earthquake, the JMA released an instant text message to the public warning them of this natural disaster, but because of their wrong estimation, people did not prepare as well as they should have. Even though there was a wrong prediction, the earthquake data was correct, so immediately, earthquake, nuclear, and industrial facilities were shut down. The earthquake first occurred at 2:46:45 local time, and the messages and reports went out at 2:46:48, only 3 seconds later. Since tsunamis are harder to predict, the warning for the tsunami came about 9 minutes after the earthquake. Thanks to the area mail disaster system, people were informed quickly and had about 15 minutes to prepare themselves before the wave arrived. After the event, there were many measures taken in attempts to restore the affected areas. 100,000 members of the Japanese Self-Defense Force were dispatched to the areas most heavily affected. Japan requested that U.S. military forces be stationed in Japan to help with relief, and a U.S. Navy ship was also dispatched to the area. Many countries sent search and rescue teams. Those countries include Australia, China, India, New Zealand, South Korea, and many more. In addition to the military search and rescue teams relocated to Japan, there were dozens of governmental and non-governmental organizations establishing relief funds in attempts to raise money for relief, rescue, and money. According to Japan's foreign ministry, 116 countries and 28 international organizations offered assistance. It was initially very difficult to dispatch relief services there, as there were 403 aftershocks. Yet when these subsided, dozens of rescue and relief teams flew to the worst-hit areas. The Tohoku earthquake and tsunami had a devastating impact on the community, with a total of 15,800 people dead and 2,200 people missing even after 18 months. 127,000 buildings collapsed, and around 4.4 million households in northeastern Japan were left without electricity and 1.5 million without water. As of March 2012, the Japanese government has recognized 1,331 deaths as indirectly related to the earthquake and tsunami, caused by harsh living conditions after the disaster. As of March 2012, the Japanese government has recognized 1,331 deaths as indirectly related to the earthquake and tsunami, caused by harsh living conditions after the disaster. As of April 2012, 18 people had died and 420 had been injured while participating in disaster recovery or cleanup efforts. More than 500,000 have been displaced, and 163,000 people were living in shelters around the country following evacuation. Due to the meltdown of the Fukushima nuclear reactor and subsequent spillage of radioactive substances, citizens living near the area had to evacuate due to the high levels of radioactivity. This had severe repercussions as most people in the area were elderly. The cold weather only served to further disrupt transportation routes, making relief efforts difficult. The Fukushima nuclear meltdown was triggered by a combination of the earthquake and the subsequent tsunami. The earthquake shut down the main power source of the plant, and so the emergency diesel generators located on-site began to power the cooling system. However, the tsunami, which arrived 15 minutes after the earthquake, topped the 10-meter-high seawall surrounding the plant, flooding the generators. Without a working cooling system, the nuclear fuel overheated and discharged dangerous amounts of radioactivity in the surrounding waters. This caused the contamination of nearby seawater samples, showing elevated traces of radioactive isotopes. The amount of iodine spiked to 3,355 times the legal limit for seawater. This has caused civilians living near the contaminated area to be evacuated to a safer area, less exposed to the radioactive substance. Minuscule traces of radiation have been picked up as far away as Southern California, as radioactive fallout can travel with the winds, showing that the radioactive spillage does not only affect Japan and its nearby areas, but countries on the other side of the world. This also affected the water quality and marine life by either killing them outright or passing radioactive material up the food chain. Some scientists worry that the higher frequencies of ionizing radiation has changed the DNA in marine life, which can be passed on to their offspring. Several beaches were washed away and freshwater habitats were inundated with salt water. This affected drinking water for the whole ecosystem, including humans. The abundance of salt water can also drown or dehydrate plant life. The region hit by the tsunami is reported to produce over a quarter of the nation's rice. With the rice fields being infertile, this not only affects the entire Japanese economy, but local farmers in particular will now have to find a new industry or relocate. Damaged coastal waterways needed to be drained in order to be functional again, and the sewage network damage potentially caused cross-contamination, further deteriorating the health and well-being of the population. The aftermath has left Japan's coastal cities and towns with nearly 25 million tons of debris. In Ishinomaki alone, there were 17 trash collection sites, 180 meters long and at least 4.5 meters high. An official in the city's government trash disposal department estimated that it would take 3 years to empty these sites. As over 125,000 buildings collapsed, they all have to be rebuilt again, leaving more waste at their collection sites, worsening the environmental footprint. With industrial production suspended in many factories, farmland and soil being ruined, the need of rebuilding workspaces costed Japan even more. The damage closed down key ports and airports that disrupted the global supply chain. Japan's economy had just started to recover, as the GDP had just increased by 3%. However, the tsunami and earthquake was a step back and only added to Japan's economic challenges. To make matters worse, the tourism industry was affected as people were hesitant about being in an environment polluted with an abundance of radiation. Japanese food exports also suffered as people felt unsafe eating produce they believed to be contaminated by radiation. Overall, the social, environmental, and economic impacts were drastic in Japan. Lives were lost, people displaced, without clean water and a stable food supply. Beaches were also demolished, which thus affected the ecosystem. The crippling costs of the disaster demonstrated the loopholes in the disaster mitigation of the Japanese government. In conclusion, Hong Kong is not in serious danger of experiencing the type of tsunami that struck Japan. It is situated 600 kilometers from the nearest fault line, and so earthquake-induced tsunamis have always been rare. However, in the wake of the 2004 tsunami, Advanced warning systems housed in the Hong Kong Observatory have been put in place. The example of failed tsunami mitigation in Japan proved deadly for many of those who were affected. It should serve as a testament to the importance of treating a tsunami like the incredibly destructive force of nature that it is.